Hi everyone, welcome to Math World. This video is to discuss Cambridge International Examinations Mathematics Paper 4, which is a Mechanics 1 for May-June 2015, and the code is 9709/42. Alright, so let's move on to question number 1. Okay, question number 1. One end of a light inextensible string is attached to a block. The string makes an angle of 60 degrees above the horizontal and is used to pull the block in a straight line on a horizontal floor with acceleration 0.5 meter per second squared. So this is the A. Now the tension in the string is 8 Newton. The block starts to move with speed of 0.3 meter per second. For the first 5 seconds of the block's motion, find the first part, the distance traveled. The second part is the work done by the tension in the string. Okay, so basically this is the floor and here is the block. Okay, this block is pulled by a string with tension 8 newtons, and then the angle is 60 degrees. Alright, and it's mentioned that the A is 0.5 meter per second squared, and then the initial, when t equals to 0, your u equals to 0.3, the initial speed. Now you need to find for t equals to 5, so t equals to 5, what is the distance traveled? What is the s? That is the first part of the question. Okay, now from here, to get the distance, our solution is using s equals to ut plus half at squared. So the u is given 0.3, the t is 5, plus half. A is given 0.5, this is the value, and then again the t is 5, so you square it. And then at last you will get 7.75 meters. Okay, so we can use this formula because the block is moving in a straight line on a horizontal floor, which is a linear motion. Now, second part, the work done by the tension in the string. Now, from here, I will say that second part, work done by the tension, right? That is, work done formula is basically Fs. So now I need to find what is the F. So for information, because the block is moving horizontally, alright, the S is 7.75 meters. So the F must be in the same direction as the S. Therefore, I have to resolve this T horizontally. So when I resolve this T horizontally means that I'm resolving using the 60 degrees. Therefore, my F is going to be T cos 60 degrees. That is my F. Okay, and then my S is going to be 7.75. Now, given that the T is 8, so I will get 8 cos 60 degrees times 7.75. Then at last, when you calculate this value, it's going to be 31 joule. That is the work done. Okay, now for question number 2. The total mass of a cyclist and his cycle is 80 kilograms. The resistance to motion is 0. Now, first part, the cyclist moves along a horizontal straight line working at a constant rate of p watt. So when you look at the units here, watts means that is a units for power. That means the p is a power, right? Now find the value of p given that cyclist speed is 5 meter per second when his acceleration is 1.2 meter per second squared. Now I assume, okay, this is the cyclist together with its cycle. So the M is 80 kilograms. Now, it is moving along a horizontal straight line. So this is the direction. So it means that now the power is P watt. And then the cyclist speed. So the speed, let it be U equals to 5 meter per second. and then the acceleration is 1.2 meter per second squared. Okay, now we need to find what is the P. That is the first part. So from here, I will use the formula power equals to F times V, whereby the F here is driving force. Alright, so now power is P, so I'll let it be P. Driving force, we do not know how much is that, but then the V here is actually the speed, which is our 5. Then now, my F is going to be P over 5. Okay, and now since the cyclist and the bicycle and the cycle is moving, means that we can use the Newton's second law. So now, F equals to ma. Okay, and from the question it mentioned that the resistance to motion is 0, so there is no resistance force here. That means your F here is just the driving force. Therefore, I will replace by P over 5. Okay, there's no resistance force, so minus 0. So just leave it this form. Equals to, the M is going to be 80. And then the A is given 1.2. Okay, so now at last your P is 5 times 80 times 1.2. Therefore, you will be getting 480. That means the power is 480 watt. So that is the solution for first part. Now, for second part, the cyclist moves up a straight hill inclined at an angle alpha, where sine alpha is this value. Okay, so now I'll draw the hill first. Let's say this is the slope. This is alpha. Okay, this is the cyclist together with the cycle. Then here is going to be 80g, the weight. And then the sine alpha is 0.035. Now, find the acceleration of the cyclist at the instant when he is working at the rate of 450 power. So now you need to find what is the A. Okay, what is the A? This is going up. What is the A? When the power is 450. Okay, and has speed 3.6 meter per second. So U is 3.6. So now you need to find what is the A. Okay, so same as just now, you have to redo for the power. So now P equals to F times V. Okay, so now our F is a driving force. So now my P is 450. Driving force is unknown. Then the speed is 3.6. That means now my F is going to be 450 divided by 3.6. Therefore, you'll be getting 125. That's a driving force. And then now again, I use Newton's second law, because now you need to find what is the A. So now, in the question, again, it is resistance to motion is 0. Okay, but then now when you look at here, we have to consider the weight, right? So if here is alpha, now this is a driving force, F. That means you have to resolve this 80 grams or 80g, not 80 grams, 80g along the plane. That will be the force which is opposite the motion. Okay, and now when I resolve it along the plane, so I am not using its angle, but I'm going to use the alpha value here. Okay, so for your information, this is alpha. Alright, so what we do here is, since you are not using its own angle, so when you resolve, you have to use sine of the alpha. So now my F becomes 125, okay, because of here, minus 80g, then sine alpha, after you resolve it to the to this force. Okay, now then right hand side, the M remains as 80, the A is unknown. So from here I will get 125 minus 80, the G is 10, sine alpha is given 0.035, then equals to 80A. So the left hand side, when you calculate, you will get 97. Then right hand side is 80A, therefore your A is 97 divided by 80, and at last you'll be getting 1.21 meter per second squared. So this is the solution for part 2. Okay, now for question number 3. A plane is inclined at an angle of arc sine 1/8 to the horizontal. A and B are 2 points on the same line of greater slope with A higher than B. Okay, so now this is the slope. Here is alpha. A higher than B. Let's say here A, here B. This A, this is B. Then now I will say alpha is inverse sine 1/8. Therefore, sine alpha will be 1/8. Now, AB distance is 12. So this is 12. A small particle, okay, sorry, I should not draw particles here. It should be just the distances. Here is A, here is B. Okay, distance of 2 points. And a particle object Q of mass 8 kilogram is released from rest at A and slides down the plane. That means this is a particle P. Okay, since this is released from rest at A, that means initial initial speed is 0. Right? Then the MP is 8 kilograms. Now, passing through B with speed 4.5 meter per second. That means when the P is here, reaches here, that means the VP is going to be 4.5 meter per second. Now, for the motion P from A to B, just from A to B, find the increase in kinetic energy of P and the decrease in potential energy of P. So, for this case, right, we know that increase in kinetic energy, the formula is half mv squared. We say it is increased because initial speed is 0. So initial kinetic energy is 0. Then when it reaches B, right, it has the speed of 4.5. That means you will get the kinetic energy. Therefore, from 0 to a certain value of kinetic energy, that is considered an increase in kinetic energy. So therefore, half, your m is 8, the v is at B, okay, because this is the motion from A to B. Alright, so your B at B, the V is going to be 4.5. Then you square it. And then at last you'll be getting 81 joule. That is the increase in kinetic energy. And then now at the same time, we need to get the decrease in potential energy of P. And again, the motion is from A to B. So from here, I will write decrease in PE. Now, the gravitational potential energy formula is mgh. So we get a decrease here because initially the height is bigger. Okay, then we consider at the B, okay, the height becomes 0. Alright, so now from here, the M remains at 8, the G is 10. Now the H is basically the vertical height. This is a H. So this H can be found by resolving this 12 meters vertically. So when I resolve, right, suppose to use this angle, but then I'm using the alpha. Okay, because if here is alpha, that means here is also alpha. Right? So when I'm using alpha to resolve vertically, that means it will be sine. So which means my H is basically 12 sine alpha. Okay, so 8 times 10, 80. 12 sine alpha, from the question, it is 1/8. Therefore, you'll be getting 120 joule. So that is the first part. Now, second part, the magnitude of the constant resisting force that opposes the motion of P. Okay, so now from here, I need to refer to the work energy principle. So according to this work energy principle, increase in mechanical energy equals to total work done. Okay, so this increase in mechanical energy, including increase in kinetic energy plus increase in gravitational potential energy, which is PE. Then the total work done here means is a work done by forces to speed up the body minus work done to slow down the body. But then from here, since this is release, right? Release from rest, there is no work done to speed up the body. But then we have to minus the work done to slow down the body. So that is due to the resistance force. Right? Hang on, please. Okay, that's why the question asking for what is the magnitude of the constant resisting force. Alright, so because of you have to minus the work done against resistance. Now increase in KE we already solved in first part, which is 81 kg, 81 joule. So I will just write 81. Now the increase in PE. For the first part, we have found decrease in PE. It is 120 joule. So the formula here is plus increase in PE. Alright, so by increase in PE, it will be negative of this value because 120 is actually referring to the decrease, not increase. So you have to write minus 120. If you write accidentally write plus 120, that means there is the increase in PE and no longer decrease. Okay, so minus work done. For information, work done formula is Fs, right? So now we need to find what is the resistance force. So I let the F be Fr. Now what is the S? Look at the diagram here. The S is basically the distance traveled. Alright, therefore it is 12. So here I will write times 12. So for the left hand side, 81 minus 120, you'll be getting negative 39. Then right hand side will be negative 12 Fr. So now our Fr, okay, that will be 39 over 12. Then at last, I'm getting 3.25. So you can define what is the Fr. Fr is the resisting force or resistant force. Okay, so it means that I have solved the problem. This is your Fr. And then you can just write down the unit, which is Newton. Okay, next, question number 4. A particle P moves in a straight line at time t seconds. After starting from rest, at the point O on the line, the acceleration of P is a meter per second squared, where this is the A. Now, first part, find the expression for the displacement of P from O in terms of T. Okay, for your information, if we are given S, which is our displacement, to get the V, which is the velocity, we need to differentiate. Then from the V, to get the A, which is the acceleration, we need to differentiate for the second time. Now, you are given the A, and you need to find the S. Displacement is the S. So it means that it is reverse process. So the reverse process of differentiation is basically integration. Right? So same for the second reverse process. Means that now from A to S, we need to integrate 2 times. So for the first part, my A is 0.075 t squared minus 1.5 t plus 5. So now my V is integrate A dt. Then it will be integrate 0.075 t squared minus 1.5 t plus 5, then dt. Okay, we integrate with respect to t. So whenever we integrate, you must plus 1 degree to the variable. That means t squared becomes t cubed, then over 3, then minus 1.5, the t becomes t squared over 2, the 5 becomes 5t, and don't forget to plus an unknown. Now 0.075 divided by 3, it will be 0.025 t cubed. 1.5 divided by 2 is 0.75, then t squared, and rewrite the last 2 terms. This is my V. But then I need to get the C first. So to get the C, I need to know the T and V. So go back to the question, starting from rest. Okay, when starting from rest means the T 0, the V is 0. It's not moving. So now T equals to 0, V equals to 0. Therefore, left hand side is 0, right hand side first 3 terms will be 0, so 0 plus C. Therefore, your C is basically 0. Now I found my V. This is the velocity expression. Okay, and now based on the question, we need to find S, displacement. Therefore, I need to integrate the second time. So now my S is basically integrate V dt. So integrate 0.025 t cubed minus 0.75 t squared plus 5t dt. Okay, then again, when I integrate, it will be 0.025 t degree 3 becomes t degree 4 over 4 minus 0.75 t squared becomes t cubed over 3. The 5t becomes 5 times t squared over 2. After that, plus 1 unknown. Just now we use plus c. Okay, then now don't use plus c, you use other variable, maybe d. So now simplify first. 0.025 divided by 4, it will be 0.00625 t degree 4. Then minus 0.75 divided by 3, it will be 0.25 t cubed. Then 5 divided by 2, it will be 2.5 t squared. After that, plus d. Alright, so now again, I need to know the t and s to find the d. So again, refer back to the initial condition. When starting from rest at O, that means at that time, the s will be 0. So I will write t equals to 0, the s is 0. Therefore, left hand side is 0. For the right hand side, first 3 terms will be 0, then plus d. Therefore, again, my d will be 0. Okay, now I rewrite my s. So s is 0.00625 t degree 4 minus 0.25 t cubed plus 2.5 t squared. So this is my displacement. Okay, so with this, I have completed question number, the part 1, sorry. I have completed question 4, part 1. Okay, now part 2, hence. Hence means use the answer from previous part. Find the time taken for P to return to the point O. Okay, so now for the part 2, when the P returns to point O, that means the displacement is 0. Okay, let's say for example, this is your P. Okay, reach here. This is the starting point. I will say this is the starting point O. This is the particle P. So it moves to the right side. After that, it goes back. Right? So when it goes back means that the displacement will be 0. So now I will write s equals to 0. So since we have found the s expression here, just replace the s by 0. So 0 equals to 0.00625 t degree 4 minus 0.25 t cubed plus 2.5 t squared. And now the question is asking for time. We need to solve the t. Okay, so from here, I notice that the t squared is in common. Right, so it means that here I can factorize the t squared. Okay, so we factorize the t squared, and at the same time, here I can just divide the whole equation by 0.25. Okay, so divide by 0.25, and then I will simplify first before I factorize the t squared. Okay, so here is going to be 1 over 40 t degree 4 minus t cubed plus 10 t squared. Then I will factorize the t squared, and at the same time I times 40. So 0 is, this is t degree 4 minus 40 t cubed, then plus 400 t squared. And then now I will factorize the t squared because t squared is in common. Then I will get t squared minus 40t plus 400 equals to 0. So when you get this, right, means that multiplication of two terms equals to 0. Either first term equals to 0 or the second term equals to 0. Then from here, when t squared equals to 0 means that your t equals to 0. But then for the quadratic equation, I can factorize this into t minus 20 squared, then equals to 0. So which means your t minus 20 is 0, hence your t equals to 20. Now, obviously, okay, you need to find the time taken for p to return to O. Means that it cannot be 0 because when t equals to 0, that is the initial condition. That means it has not moved yet. Alright, so now my final answer will be t equals to 20. Okay, so the particle P needs 20 seconds to return to the point O. Alright, now next question, number 5. A particle P starts from rest at point O on a horizontal straight line. P moves along a line with constant acceleration. So when constant acceleration means that the constant acceleration, okay, now with constant acceleration and reaches a point A on the line with speed 30 meters per second. Okay, so basically it's like this. This is a P. Here is the O. Start with rest means UP equals to 0. Reaches point A. Let's say this is a point A and this is the speed. So VP is 30 meters per second. Now at the instant that P leaves O, a particle Q is projected vertically upwards from the point A with a speed of 20 meters per second. Okay, which means now here actually there is a particle Q, right? So when the P starts moving, this Q going up, projected upwards with speed UQ, okay, UQ. So here UQ equals to 20 meters per second. Now, subsequently P and Q collide at A, means that the Q reaches the highest point, then after that goes down, then collide with the P. Now, find the acceleration of P. So what is your P here? What is the acceleration of P, given that it is a constant acceleration? Okay, so from here, I need to find out how much time that taken by the Q to go down to the initial position, to come back to the point A. Okay, so now from here, the easiest way is I just find out how much time that Q takes to reach the highest position. So when the Q is at the highest position, the VQ will be 0 because it will stop a while, then only it goes down. So now from here, okay, I will write when Q reaches the highest position, right? So the VQ will be 0. Then I need to find what is the time. So once you have found the time, then I will know how much is the acceleration of P, because it moves with constant acceleration and reaches point A. So the time taken for the Q to reach the A, to come back to the A, it will be the same as the particle P to reach the point A. So now I will write, this is referring to the particle Q. I will say V equals to U plus AT. So the V will be 0 at the highest position. The the U for the Q will be 20, plus A is, because now it is moving up, right? That means the A is going to be negative 10. Then now I will get negative 10. The T is unknown. Therefore, from this diagram, I know that 20 equals to 10t. Therefore, T is 2. So I need 2 seconds for the Q to reach the highest point, highest position. So now, if the Q needs 2 seconds to reach the highest position, so it also needs the same time interval to come back to the initial position. That means now, when Q returns to A, okay, when Q returns to A, the total time taken by Q, it will be 2 plus 2. That will be 4 seconds. Okay, so when it comes back to A within 4 seconds, means that the P already reaches point A, so that they will collide at A, right? So now, when T equals to 4 seconds, Q reaches, not Q, P. Okay, P reaches point A. Okay, so now, when P reaches point A, then you are given the speed, which is 30. Okay, the final speed of the P is 30. Initial speed is 0. We do know what is the A, but then we know that the time taken is 4. So then we can just use the same formula, V equals to U plus AT. This is referring to the particle P. So V is 30, U is 0, the A is unknown, and the T is 4. Okay, so just use all the information. Then now from here, 30 equals to 4A. Hence, I will be getting my A equals to 30 over 4, which is 7.5 meter per second squared. So that is the acceleration taken, the acceleration by the particle P. Right? Now, second part, the distance OA. So all these are the solution for first part. So the distance OA, what is the distance here? That means you need to find what is the S, right? So from here, what is the S? So we know that the point P will be reaching point A within 4 seconds, right? And then the U is given, V is given, A already found. Therefore, we can just use the S equals to UT plus half AT squared to find the distance. So initially the U is 0. U times 4 plus half. The A already found in the previous part, which is 7.5. Then the T will be 4. Then at last, when you count the second term, because first term will be 0, second term will give you 60. So it means that the S is 60 meters. Or in other words, the distance OA. Okay, so distance OA is our S, which is 60 meters. So that's the solution of this question. Okay, now next question, number 6. You are given figure 1 and 2. Two figures here. Two particles P and Q, okay, P and Q have masses m kg and 1 minus m kg. So here it will be 1 minus mg, that is the weight, and then this is going to be mg. Now, the particles are attached to the ends of a light inextensible string which passes over a smooth fixed pulley. P is held at rest with the string taut and both straight parts of the string vertical. P and Q are each at the height of h meters above horizontal ground. Okay, so here is a h. Right, that's the distance. Now P is released and Q moves downwards. So that means that Q moves downwards. That means that P will move upwards. Subsequently, Q hits the ground and comes to rest. So the Q will reach here. Okay, the Q will reach here. This is the Q. Now, figure 2 shows the velocity time graph for P, while Q is moving downwards or at rest on the ground. Okay, this is for P, particle P. Now, first part, find the value of H. Okay, so to get this, we know that H is a distance traveled by the Q, okay, because the Q goes down or the P goes up by H meters. Now, when you look at this diagram, the figure 2, that is velocity time graph, which means this is to get the displacement because the V is a velocity, right? So I will say that area under the curve here will be the distance or will be the displacement traveled by the P. Okay, here is the highest is 2 for the velocity, means that now your particle Q will reach up to the maximum. This is a Q, P is P, sorry, this is a P. Okay, it will be reaching here, that is a maximum. That means this Q will go down. Okay, so means that here is H meters. That is the maximum height or maximum distance that the P can travel before the Q just touches the ground. Alright, so from here, to get the H, which is the distance, I will just use area under the curve here. Alright, so you just count the area under the curve when it reaches the highest speed for the particle P. That means here is going to be the area of this area of this triangle. Okay, so now for my solution, I will just write the displacement equals to area under the VT curve. Okay, so now the H is my displacement, which is area of the triangle. So now my width, my base is 0.5 and my height is 2. So I will just times these two together. That will be my area. So obviously the half and 2 cancel off. Then your H is 0.5 meters or 0.5 because it's mentioned HM. So now I get my H is 0.5. Alright, so now part 2. Find the value of M and also the tension in the string while Q is moving. So when Q is moving, we need to refer to the Newton's second law. Alright, so from here, Q moves down, and then here you have the tension. This is a tension. Alright, so now I will use F equals to ma, Newton's second law. So for the P, right, for the P. So now for your information, I need to know the A first. Okay, so the A can be found by referring to the graph. So A equals to V over T. And I know that the particle P reaches this speed, right, 2 meters per second within 0.5 seconds, right? Therefore, the V is 2, the time is 0.5. That is my acceleration, which means I'm getting 4 meters per second squared. Okay, after this, I will just substitute into the A here. Now, when I refer to the particle P, the B is moving up. Therefore, the tension minus the mg, it will be the ma. So now I will get T minus mg equals to ma, because the mass for the P is m. Now, for the Q, okay, for the Q, the Q moves down. That means 1 minus m times g minus T equals to 1 minus ma, because the mass for the Q is 1 minus m. So from here, I will write 1 minus m times g minus T equals to 1 minus m times a. I have found the a. A is 4. That means for the first equation, I will get T equals to 4m, because your a is 4. So 4m plus mg. So remember the g is 10, right? Therefore, it will be 4m plus 10m. At last, you are getting 14m. That is our T. Let this be first equation, and this is the second equation. So now, substitute first into second. I will get 1 minus m times 10 for the G. Okay, now you need to find m and T, tension. So, minus the T already found from the first equation, which is 14m. Then equals to 1 minus m times the A is 4. Okay, which is here. Then now, I will have to do expansion. Okay, so basically, if you want to do expansion first, you will notice that 1 minus m is in common. Then you can just move this to the left hand side. So it becomes minus 4 of the same term. So 10 minus 4 is basically 6. So I will simplify it like that. So I will get 6 of 1 minus m minus 14m equals to 0. Okay, then now I will do expansion. 6 minus 6m minus 14m equals to 0, which means you will get 6 minus 20m equals to 0. Therefore, my 20m is 6. Hence, my m is 6 over 20, which is 0.3. So I found the m already. So after you found the m, to get the tension, I can refer to the first equation. So from first equation, the T is 14m, which is 14 times 0.3. Then you will be getting 4.2 newtons. So that's the answer for first part. Oh, sorry, second part. Okay, now third part. The string is slack while Q is at rest on the ground. Find the total time from the instant that P is released from string becomes taut again. Alright, so for your information, when the Q reaches the ground, the string slack. That means, let's say here is H. That means now at this position, the Q will be reaching the ground. Means that at the same time the string is slack, which means now the particle P will move up, right? Will move up freely. So we can just ignore the T now. No more tension. Then now we need to find what is the total time from the instant P is released until the string becomes taut again. Means that now, okay, when the string is slack, So this P will move up until certain level. Then after that, right, it will go down. So it will go down up to here. Then the string will be taut again. Alright. So now what we need to do here is we need to get the time. So part 3, for the points P, right? So when you look at the diagram over here, the P will be having -2 velocity, right? At first it's positive 2 velocity. I mean the velocity is positive 2. It moves up. It moves up. Now when it is -2, okay, so the initial is positive 2 and the final velocity is -2. So now from here I need to find how much time it takes to reach -2, because going up is positive, okay, going down will be negative. Means that when I calculate this 2 to -2 for the V, that means it's already reaches here, right? Go up and go down, which is the red color, up and down. So up and down. That's why when goes down, that is V equals to -2. Okay, so now from here I just need to find what is the time taken for this, right? Then I just need to plus with the time taken from the points P to go up to the H. Then total of these two times will be the requested answer. So that's why now from here I will use back V equals to U plus AT. Okay, so your V is -2, your U is 2, and then the A is -10 because it is moving down, right? When the V equals to -2. At first moving up, now moving down. So then here, the T is unknown. Therefore, I will get -4 equals to -10t. Then now my T will be 4/10, which is 0.4 seconds. This is to go back to the H meters here, right? So it means go up and down, I get T equals to 0.4 seconds. And now I need to get the total, because the question says that you need to find the total time from the instance that P is released, right? So the whole process. So now, just now we have found, oh no need, okay, just now when you refer to the graph here, okay, so from 0 to 0.5 seconds, the P already reaches, I mean the speed of the P changes from 0 to 2, and this 2 is the highest. That means it will be here, right? That means from P, the initial position, up to the H meters, the time is basically 0.5 seconds. It's given in the graph. So now I have found just now the time equals to 0.4. So the whole process, it will be just add up these two time. So then my total time it will be just 0.5 seconds plus 0.4 seconds, end up with 0.9 seconds. So that's the solution of part 3. Okay, now question 7. A small ring R is attached to one end of the light inextensible string of length 70 centimeters. So here 30, here 40, therefore 70 centimeters. A fixed rough vertical wire, so this is the rough vertical wire, passes through the ring. The other end of the string is attached to point A on the wire. So this is the point A, vertically above R. A horizontal force of magnitude 5.6 Newton is applied to point J of the string 30 centimeters from A and 40 centimeters from R. So it is to explain 40 and 30 centimeters here. The system is in equilibrium. Equilibrium means that it's not moving. with each of the parts AJ and JR of the string taut. Okay, and angle AJR equals to 90 degrees. Here is 90 degrees. Now, first part, find the tension in the part AJ of the string and find the tension in the parts JR in the string. Okay, so now here we have two tensions, and then I will just refer to the point J here. Alright, so I will redraw the diagram. Means that now A on top, A is above of the R. So A, here is A, and this is R. Okay, then here is 90 degrees. Right, so let me redraw, because the AJ is 30 centimeters, so I have to redraw my diagram. Right, AJ is shorter, RJ is longer. Okay, so and this is a J. So this is a J. Alright, so this is my A. Now, I will label this as TA, tension of the AJ, and then this is a tension of JR, so TR. And then we know that 40 centimeters, here is 40 centimeters, and this is 30 centimeters. The horizontal force is 5.6. Okay, now I need to know what is my AR. Okay, since the AJ is perpendicular to RJ, that means the AR is the hypotenuse. Right? So my AR, according to the Pythagoras theorem, it should be square root of 30 squared plus 40 squared, which is 50. So here I will label as 50. Okay, now the question is asking for TA and TR. What is TA and TR? So TA equals to question mark, TR equals to question mark. Now for this case, I will refer to the points J. So at J, right? So the horizontal force. Now, for your information, okay, if I let here be alpha, because I know that this is 90 degrees, AJR is 90 degrees. If here is alpha, then here is going to be pi over 2 minus alpha, or probably I can just let it be beta. Alright, so from here, I will say when you resolve, right, when I resolve horizontally, and this is going to be my 90 degrees, right? So the angle here, right, if here is 90 degrees, this is alpha, that means here is beta. If here is beta, this is beta, that means here is going to be alpha. Agree? So that alpha plus beta is pi over 2. Okay, so from here, now you can say that 5.6 is the force towards the right hand side. So when I resolve the TR horizontally, I will get TR sine alpha. You can write cos beta or sine alpha, up to you. Okay, if I don't want to label here, what I will do here is I will just say this is my alpha. Okay, and use the property of the angle. This is going to be my beta. Now, when I resolve the TR horizontally, I'm not using its own angle, but I'm using alpha. Therefore, I use sine. Okay, so you can use that method. And then plus with the TA, when you resolve horizontally, I'm not using its own angle, but I'm using beta. So it will be sine beta. Okay, now what are the values for sine alpha and sine beta? So now for your information, sine alpha, okay, here, this is alpha, here is 90 degrees. So opposite side of alpha is 30. Right? Sine is opposite over hypotenuse. So opposite side is 30. Hypotenuse is 50. Therefore, 3 over 5. And then now I need sine beta. So for sine beta, again, opposite side of the beta is 40 centimeters. Hypotenuse is 50. Therefore, you are getting 4 over 5. Okay, then now from here, I will get 5.6 equals to sine alpha is 3 over 5 TR. Then sine beta is 4 over 5. Then TA. This is my first equation. Now, second equation is going to be referring to the vertical force. So when vertical force, the 5.6 will not be taken into the consideration because that is a horizontal. What I need to do now is I need to resolve TA vertically and TR vertically. So when I resolve TA vertically, it is pointing up, and then the TR is pointing downwards. Therefore, it will be balanced back. Alright. So now when I resolve TA vertically, I will get TA cos beta because I'm using back its own angle, which is a beta. Then equals to TR cos alpha as well. Okay, now I need to get cos alpha and cos beta. So cos alpha, cos is basically adjacent over hypotenuse. So adjacent side of the alpha is basically 40. This is the adjacent side, and then the hypotenuse is 50. So you will get 4 over 5. And then cos beta, adjacent side, okay, for the beta, opposite side, I will say opposite side is 40. So it means the adjacent side is 30. Hypotenuse is going to be 50. So 30 over 50. So you will get 3 over 5. Then now, TA cos beta. Cos beta is 3 over 5 TA. Then cos alpha is 4 over 5. Then TR. Okay. So now from here, I will get my TA as a subject. Now, both also over 5, so I can cancel the over 5. This 3 I will move down. That means you will be getting 4 over 3 TR. So this is my second equation. Because now we need to solve for TA and TR. So now I substitute second equation into first equation. So 5.6 is 3 over 5 TR, remain the TR, plus 4 over 5 TA. So the TA will be replaced by 4 over 3 TR. Okay, so now I will get 3 over 5 TR plus, this is going to be 16 over 15 TR. So at last you will be getting 5 over 3 TR. Then my TR is going to be 5 over 3 times 3 over 5. Sorry, 5.6. Okay, my TR is going to be 5.6 times 3 over 5 because I need to get the TR as a subject. Then at last you will be getting 3.36 Newton. Okay, that is my TR. And then now from the second equation, I can get my TA. So from second equation, my TA is going to be 4 over 3 times 3.36. Therefore, you will be getting 4.48 newtons. Okay, so I have found two tensions. So then you can just write down tension in AJ, which is TA equals to 4.48 newtons, and tension in JR, okay, in JR, which is a TR, I will get 3.36 Newton. So that's the solution for first part. Now, the ring R has mass 0.2 kilograms and is in the limiting equilibrium on the point of moving up the wire. So show that the coefficient of friction between the R and the wire is 0.341, correct to 3 significant figures. Okay, so now when you look at the diagram here, there is the ring R here. Okay, so it's mentioned that when it is at the limiting equilibrium, the point, it is on the point of moving up. So when moving up means that the frictional force is moving down. So this is Fr. And now Fr is mu R. You need to show this mu is 0.341. This is what you need to solve now. Okay, so what I need to do here is I will resolve vertically at the point R. Okay, so now when I resolve, so for the second part, this is at the point R, so I will get TR cos. Okay, probably I will refer back to this diagram. So I add on the ring here. This is the ring. Then you have the FR. Alright, so I will get TR cos alpha. Okay, because my TR will be two ways. So here is also TR. Now I will just draw the R. Okay, I will just redraw this part in the second part here. Then it will be easier to refer to. So now this is the R. Here you have the FR. Okay, and then here you have the tension TR. TR already found just now. So TR is 3.36. And then don't forget the ring has the mass of 0.2 kg. So the ring has the mass of 0.2 kg, so the weight is 0.2 g. So from here, right, and don't forget this is alpha. So now I refer to the vertical force, right? So I resolve this TR vertically, and then it is in the limiting equilibrium. So it is still not moving yet, right? So I will get TR cos alpha because I'm resolving using the own angle, its own angle, then equals to FR plus 0.2 G. Alright, so now what is my R first? So basically the R is, okay, where is my R? R is going to be, okay, now let me check. My R is horizontal. Okay, this is my R. Okay, so my R, you have to resolve TR horizontally. That means this is going to be TR. So you resolve the TR horizontally, but not using its own angle. I'm using the alpha. Therefore, it's sine alpha. So refer back to just now. Sine alpha is 3/5. So here I will get TR is 3.36. So 3.36 times 3/5. Then you will be getting 2.01. Okay, and then now let's say this is the first equation, this is second equation. Now I substitute second into first equation. So now my TI is 3.36, and then the cos alpha from the previous part, 4/5. So here is going to be 4/5. That equals to FR, we do not know, but that is mu R. Okay, so now FR is mu R, so mu R plus 0.2 G is 10. So now the R I have to replace by 2.01. Oh, sorry. The R, when you calculate, it will be 2.016. Okay, 2.016. So from here, I will count this value on the left hand side is going to be 2.688. then equals to, the mu is unknown, the R is 2.016, so 0.2 times 10 is basically 2, so plus 2. Now these two move to the left hand side, so I will get 0.688. Okay, or if I do it step by step, I will write 2.688 minus 2 equals to 2.016 mu. So I will get 0.688 equals to 2.016 mu. Therefore, your mu is 0.688 divided by 2.016. Therefore, you will get 0.341. Okay, so that is the mu value that you need to show. So this is shown. Okay, now a particle of mass mkg is attached to R. Okay, so here, because I normally write F equals to mu R. Okay, therefore I use the R here. This is actually the normal reaction, right? So if you don't want to get confused, probably you can just write N. If you want to change, instead of R, you can change to N. So if you change to N, because you already use the R here, that means here is going to be mu N. Okay, to avoid the confusion, right? Now, for the third part, the mass mkg, a particle of mass mkg is attached to R, and R is now in limiting equilibrium on the point of moving down. So when moving down, remember the frictional force is moving up. So part 3, given that the coefficient of friction is unchanged, find the m. Okay, so now I have to redraw the diagram. So part 3, so this is the wire, right? And then this is the R. This is the ring as R. And now, initial ring, okay, initially the ring has mass 0.2 kg. And now you add on one more particle with the mass of m kg. That means now, when I consider the ring together with the mass, with the particle, that means the mass becomes 0.2 plus m kg, and then the weight will be just multiplied by g here. Okay, and don't forget you still have the tension in the R. The TR remains as 3.36, and again here is alpha. Okay, here is 90 degrees. Alright, now in the question is mentioned that it is now in the limiting equilibrium and on the point of going down. So when going down, we will have the frictional force going up, right, pointing up. This is our frictional force, so Fr. And it's mentioned that the mu is unchanged. Coefficient of friction is unchanged. Find the m. So from here, to get this solution, what I need to do is I will use back the Newton's second law, F equals to ma. So F equals to ma. Now, I need to resolve this TR vertically. So when I resolve, it will be pointing up. Okay, so I will resolve vertically. So which means 0.2 plus m times g, this is the only force pointing downwards. And then for the upward force, I will have the Fr together with the TR after you resolve it. So it will be TR cos alpha, because I'm resolving the TR using the angle alpha. Okay, and now you need to find the m. So for the left hand side remains the same, but the g you can change to 10. So Fr here, Fr is always a mu times the normal reaction. Okay, the mu is unchanged, which is 0.341, and then the normal reaction, it will be the same, 2.016. Okay, because it is the same wire, 2.016 plus TR. So the TR just now we already found in the beginning, 3.36. Then the cos alpha from the first part. So from first part, my cos alpha is 4/5. Okay, so now need to replace the cos alpha by 4/5. Then for the left hand side, I will do expansion. These two values multiply by 10. So 0.2 times 10, it will be 2. Then 10 times m, it will be 10m. Now, for the right hand side, you can just get the total of these two terms. It will be 3.37. I give more decimal places, 5456. Okay, therefore my 10m, you just minus from 2, means that it will be 1.375456. That means my m just divide by 10, I will get 0.137546, and we always leave the answer correct to 3 significant figures. Therefore, look at the fourth significant figure, it is 5 and above, so I round up. So the final answer is 0.138. This is your m. Okay? So with this, we have completed the part 3 of this question. Okay, so we also come to the end of the question paper. Alright, so thanks for watching this video. Please subscribe to my channel and stay tuned for more upcoming videos. Thank you. Bye.